So, good day everyone. My name is Bernie Silio and I will be the presenter for the portfolio models and asset allocation. In asset allocation, it involves determining how to allocate investment funds across a variety of asset classes such as stocks, bonds, mutual funds, and real estate. In an asset allocation, its goal is to minimize the volatility and maximize. So when we say volatility, it refers to the speed or degree of a change in the prices in the financial market. So as the volatility increases, the potential to make more money quickly also increases. However, the bad news is that the higher volatility, then the higher the risk is. Then in portfolio models are used to determine the percentage of the funds that should be made in each asset class. So kaning portfolio models, usa ni siya ka effective method which is simple, time-tested, and requires very little work on our part. So kaning model portfolio, kay mo na siya diversified system of a mutual fund that are grouped together to provide an expected return with a corresponding amount of risk. So kanining diversified system, usa na siya ka technique na nag-reduce sa risk by allocating the investments across various financial instruments, industries, and other categories. So by using these portfolio models, kay makatabang siya sa investor to manage the risk and reduce the volatility of an asset's price movements. Then the goal of the portfolio models and asset allocation is to create a portfolio that provides the best balance between risk and return. Then in this section of the portfolio models and asset allocation, we're going to use the linear programming models to determine the optimal portfolio involving the mix of the mutual funds. So there are two types of models in a portfolio models. So the first model is designed for conservative investors who are strongly averse to the risk. So when you say risk averse, kay na-describe niya siya sa usa ka investor na who chooses the preservation of a capital over the potential for a higher than average return. Then the second model kay gi-design siya for investors with a variety of risk tolerances. So mo ni siyang mga investors na willing mo stand sa ilang investments bisag dako siya risk na mamakuha nila kung mag-invest sila sa ilang funds. Then, in creating a portfolio model, kay first we need to determine the mutual funds that are needed in the problem. For example, in a Hawk Investment Services, kay gusto nila mo-develop a portfolio model na can be used to determine an optimal portfolio involving a mix of 6 mutual funds. So, in this table 5.4, it shows the portfolio of mutual funds of the 5 selected years, which is used as the planning scenarios for the next 12 months. So, ang 6 mutual funds niya diri kay mo ang foreign stock, intermediate term bond, large cap growth, large cap value, small cap value, and small cap growth. Then, ang kaning annual return kay nagrepresent ni siya sa 5 ka years for the 6 mutual funds. Then, the year 1 diri kay nagrepresent siya diri sa year in which the annual returns are good for all the mutual funds. So, nagsulti siya good diri kay tungod ang annual return na makuha nila kung mag-invest sila sa mutual fund, sa 6 kabok mutual fund, kay positive ilang makuha. Then, sa year 2, kay conscious siya, good year siya kay tungod ang ilang annual return na makuha sa 6 mutual fund kay positive. Pero pag abot sa year 3, bad year siya kay tungod ang makuha magud sa bad year siya for the small cap value kay ang annual return na kay negative 6.70. Then for the year 4, bad year siya tungod para sa intermediate term bond kay tungod ang iyang annual return na makuha kay negative 1.33. Then for the year 5, ang kani siya kay bad year ni siya for the 4 out of the 6 mutual funds, which are the foreign stock, the large cap growth, the large cap value, and the small cap growth. Then in this portfolio model of Hawk Financial Services, it shows that the scenarios that can be used to represent the possibilities for the next year. and assume that one of the 5 possible scenarios kaning year 1, year 2, year 3, year 4, and year 5 will describe the return over the next 12 months. Then, in a conservative portfolio kay sa problem kay one of the Hawks portfolio managers kay gias siya sa develop gias siya na mo develop og usa ka firms o usa ka conservative na model who express a strong aversion of the risk, and the manager task niya kay to determine the proportion of the portfolio to invest in 6 mutual funds so that the portfolio provides the best return possible with a minimum risk. Then in making the conservative portfolio, we're going to use the linear programming models in developing the portfolio. So in this table 5.4, we're going to use the table 5.4. I mentioned in a portfolio models, the risk is minimized by diversification. So to see the value of the diversification, okay, suppose we first consider investing the entire portfolio in just one of the 6 mutual funds. For example, the client run the risk of losing 21.93% over the next 12 months if the entire portfolio is invested in the foreign stock mutual fund. So kung ang investor kay gusto niya na ang iyang entire portfolio kay gusto niya invest sa foreign stock, then ang iyang makuha na loss kay 21.93%. Then also for the intermediate term bond fund, kung imo siyang i-invest ang entire portfolio nimo, then ang makuha nimong loss kay negative 1.33%. Then for the large cap growth fund sad kay makuha nimong loss kay 23.26%. Then also for the large cap value fund, ang ma-loss nimo kay 5.37%. Then for the small cap growth fund, ang makuha nimong losses kay 9.02%. And for the small cap value fund, ang makuha nimong losses kay 6.70%. Now, to determine the proportion of the portfolio that will be invested in each of the mutual funds, we use the following decision variables. Fs equals the proportion of the portfolio invested in the foreign stock mutual fund. The IB, which stands for intermediate term bond fund, which is the proportion of the portfolio invested in the intermediate term bond fund. The LG equals the proportion of the portfolio invested in the large cap growth fund. LV equals the proportion of the portfolio invested in the large cap value fund. SG equals the proportion of the portfolio invested in the small cap growth fund. Then the SV equals the proportion of the portfolio invested in the small cap value fund. And because the sum of this proportion must equal to 1, we need the following constraints, which are the Fs plus IB plus LG plus LV plus SG plus SV is equal to 1. Then, let us now introduce the variable M. So, kaning variable M, nag-represent ni siya sa minimum return for the portfolio. So, as we have already shown, one of the 5 possible scenarios in the table 5.4 will determine the portfolio return. Thus, the minimum possible return of the portfolio will be determined by the scenario which provides the worst case scenarios. Then here, we can get the portfolio return over the next 12 months depends on which the possible scenarios from year 1 to through 5 in table 5.4 occurs. So let R1 denote the portfolio return if the scenario represented by the year 1 occurs. R2 denotes the portfolio return if the scenario presented by year 2 occurs, and so on. And then the portfolio returns for the following 5 planning scenarios are as follows. So here, the scenario 1 return is R1 equals 10.06 Fs plus 17.64 IB plus 32.41 LG plus 32.36 LV plus 33.44 SG plus 24.56 SB. Then for the scenario 2 return, R2 equals 13.12 Fs plus 3.25 IB plus 18.71 LG plus 20.61 LV plus 19.40 SG and plus 25.32 SV. Then for the scenario 3 return, R3 equals 13.47 FS plus 7.51 IB plus 32.28 LG plus 12.93 LV plus 3.85 SG minus 6.70 SV. Then for the scenario 4 return, R4 equals 45.44 FS minus 1.33 IB plus 41.46 LG plus 7.06 LV plus 58.68 SG plus 5.43 SV. Then for the return, R5 equals 21.93 FS plus 7.36 IB minus 23.26 LG minus 5.37 LV minus 9.02 SG plus 17.31 SV. So, kani siya mo ni siya ang mga 5 planning scenarios. The next, introduce the variable M to represent the minimum return for the portfolio. So as we have already shown, one of the 5 possible scenarios in table 5.4 will determine the portfolio return. Thus, the minimum possible return for the portfolio will be determined by the scenario which provides the worst case return. And to ensure that the return under each scenario is at least as large as the minimum return M, we must add the following minimum returns constraints. First is the R1 is greater than or equal to M, which is the scenario 1 minimum return. For the scenario 2 minimum return, which is the R2 is greater than or equal to M. The next is the scenario 3 minimum return, R3 is greater than or equal to M. Then the scenario 4 minimum return is R4 is greater than or equal to M. Then the scenario 5 minimum return, R5 is greater than or equal to M. Then after we analyze or get the minimum return for the 5 scenarios, now we're going to substitute the values shown previously for the R1, R2, and so on provides the following 5 minimum return constraints. So these are the 5 minimum return constraints. For the scenario 1, 10.06 FS plus 17.64 IB plus 32.41 LG plus 32.36 LV plus 33.44 SG plus 24.56 SV is greater than or equal to M. Next, scenario 2, 13.12 FS plus 3.25 IB plus 18.71 LG plus 20.61 LV plus 19.40 SG plus 25.32 SV is greater than or equal to M. Scenario 3, 13.47 FS plus 7.51 IB plus 32.28 LG plus 12.93 LV plus 3.85 SG minus 6.70 SV is greater than or equal to M. Next is the scenario 4, 45.42 FS plus 1.33 IB plus 41.46 LG plus 7.06 LV plus 58.68 SG plus 5.43 SV is greater than or equal to M. Then the scenario 5, negative 21.93 FS plus 7.36 IB minus 23.26 LG minus 5.37 LV minus 9.02 SG plus 17.31 SV is greater than or equal to M. And then with the 5 minimum return constraints present, the optimal value of M will equal to the value of the minimum return scenario. And then the objective is to maximize the value of the minimum return scenario. And because the linear programming model was designed to maximize the minimum return over all the scenarios considered, we refer to it as a maxim model. And to develop a portfolio that provides the best return possible with a minimum risk, we need to maximize the minimum return for the portfolio. Thus, the objective function is simple, the max M. Then the complete maximin model for the problem of choosing a portfolio of a mutual funds for a conservative risk-averse investors involves 7 variables and 6 constraints. And the complete maximum model is written as follow. Then the max M, the constraints are 10.06 fs plus 17.64 IB plus 32.41 LG plus 32.36 LV plus 33.44 SG plus 24.56 SV is greater than or equal to M. Same sa 13.12 hanto diri sa ika-scenario 5 which is kaning negative 21.93 fs. Then for the 6th constraint kaya yang fs plus IB plus LG plus LV plus SG plus SV. Next, kay ang kaning iyang non-negativity kay ang M, Fs, IB, LG, LV, SG, SV is greater than or equal to 0. And note that we have written the constraints that require the sum of the proportion of the portfolio invested in each mutual fund as the last constraint in the model. And in this way, when we interpret the computer solution of the model, constraint 1 will correspond to the planning scenario 1 and constraint 2 will correspond to planning scenario 2 and so on. And using the computer solution, we get the Hawk maximum portfolio model solution, which is the figure 5.6. So the optimal solution to the Hawk maximum model is shown in figure 5.6. The optimal value of the objective function is 6.445. Thus, the optimal portfolio will earn 6.445% in the worst case scenario. Then, yung optimal solution naa siya diri sa 55.4% of the portfolio invested in the intermediate term bond fund, kaning IB. Then 13.2% of the portfolio to be invested in the large cap growth fund which is kaning LG. And 31.4% of the portfolio to be invested in the small cap value fund, which is the kaning SV or kaning SV or 0.31 for 39. Then, because we do not know man kanang as the time of solving the model which of the 5 possible scenarios will occur kaning scenario 1, 2, 3, 4, 5, we cannot say that for sure that the portfolio return will be 6.445% ang iyang optimal portfolio. Pero kung mogamit tag using the kanang surplus variables, we can learn that the portfolio return will be under each of the scenarios. Here, diri ang kaning constraint 5 na correspond siya sa scenario 3, 4, and 5. Kaning year 3, year 4, and year 5. Then the surplus variables for these constraints are 0, which indicate that the portfolio return will be M equals 6.445% if any of these 3 scenarios occur, kaning scenarios 3, 4, and 5. Then, the surplus variable for the constraint 1 is 15.321, indicating that the portfolio return will exceed M equals 6.445 by 15.321 if the scenario 1 occurs, kaning slack or surplus, mo ni siya. Then, so if the scenario 1 occurs daw, kaya ang portfolio return will be 6.445% plus the 15.321%, which is equivalent to 21.776%. So kani siya man siyang total na optimal solution na makuha nimo kung ang scenario 1 kay mo occur siya or imong pilion na invest sa imong fund. Then referring to the surplus variable for the constraint 2, we see that the portfolio return will be 6.445% plus the 5.785% kaning constraint 2. So kung imo na siyang i-add ang iyang total kay 12.230% kung ang if scenario 2 kay mo occurs. So we must also keep in mind that in order to develop the portfolio model, the leader of the Hawk Financial Services, can make an assumption na that over next 12 months Okay, one of the 5 possible scenarios in table 5.4 will occur. But we also recognize that the actual scenario that occurs over the next 12 months may be different from the scenarios Hack considered. So maunang ang kaniyang experiences ni Hawk and judgment niya in selecting the responsive scenarios nagplay ni siyang important role kay tungod dili magod nato ma-determine kung how valuable ang kaning model recommendation para sa client. So mao ni siya para sa conservative portfolio. Next is the moderate risk portfolio. So kaning moderate risk portfolio appropriate ni siya for the investors with a medium risk tolerance. Also, ang kaning moderate risk portfolio kay bagay rin sila sa mga investors na willing mo accept og market volatility for the possibility of receiving returns with a significant margin. For instance, Hawk's portfolio manager would like to construct a portfolio for clients who are willing to accept a moderate amount of risk in order to attempt to achieve a better returns. Then suppose that the clients in this risk category are willing to accept some risk but do not want the annual return for the portfolio to drop below 2%. By setting M equals 2 in the minimum return constraints in the maximum model, we can constrain the model to provide a solution with an annual return of at least 2%. And then the minimum return constraints needed to provide an annual return of at least 2% are as follows. R1 is greater than or equal to 2 is the scenario 1 minimum return. R2 is greater than or equal to 2 is scenario 2 minimum return. Then the R3 is greater than or equal to 2, scenario 3 minimum return. Then the R4 is greater than or equal to 2 is scenario 4 minimum return. Then the R5 is greater than or equal to 2 is the scenario 5 minimum return. In addition to these 5 minimum return constraints, we still need the constraint that requires that the sum of the proportions invested in the separate mutual funds is 1. So these are FS plus IB plus LG plus LV plus SG plus SV is equal to 1. Next is the different objective is needed for this portfolio optimization problem. So in this moderate risk portfolio model, a different object is needed for this portfolio optimization problem. So atong common approach na gamiton kay kanimo maximize the expected value of the return for the portfolio. For instance, if we assume that the planning scenarios are equally likely, we would assign a probability of a 0.20 to each scenario. In this case, the objective function is to maximize the expected value of the return equals 0.2 R1 plus 0.2 R2 plus 0.2 R3 plus 0.2 R4 and plus the 0.2 R5. And because the objective is to maximize the expected value of the return, we write Hawk's objective as follows. Max 0.2 R1 plus 0.2 R2 plus 0.2 R3 plus 0.2 R4 plus 0.2 R5. Then the complete linear programming formulation for this version of the portfolio optimization problems involves 11 variables and 11 constraints. So these are the constraints for the portfolio optimization problem. So the following constraints are 10.06 FS plus 17.64 IB plus 32.41 LG plus 32.36 LV plus 33.44 SG plus 2456 SB equals R1. Then 13.12 FS plus 3.25 IB plus 18.7 LG plus 20.61 LV plus 19.40 SG plus 25.32 SV is equal to R2. Then 13.47 FS plus 7.51 IB plus 32.28 LG plus 12.93 LV plus 3.85 SG and plus 6.70 SV is equal to R3. Next is the 45.42 FS minus 1.33 IB plus 41.46 LG plus 7.06 LV plus 58.68 SG minus 5.43 SV is equal to R4. Next is the negative 21.93 Fs plus 7.36 IB plus 23.26 LG minus 5.37 LV plus 9.02 SG plus 17.31 SV is equal to R5. Then, the 7 constraints kay ang R1 is greater than or equal to 2. The 8 constraint kay ang R2 is greater than or equal to 2. Then the 9 constraint kay ang kaning R3 is greater than or equal to 2. Then the 10 constraint kay R4 is equal to or greater than or equal to 2. R4 is greater than or equal to 2. Then the 11 constraints kay ang R5 is greater than or equal to 2. Then, for the 12 constraint niya kay kaning Fs plus IB plus LG plus LV plus SG plus SV is equal to 1. Then the 13 constraint niya kay kaning non-negativity, which is the Fs, IB, LG, LV, SG, SV is greater than or equal to 0. So to get the solution for the moderate risk portfolio model, we need to use a computer solution. So in this figure 5.7, it shows that the optimal objective value is equal to 17.33. Then the following variables R1, R2, R3, R4, R5, Fs, IB, LG, LV, SG, and SV. Which stands for constraint 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. Then, in the figure 5.7, the optimal solution is shown in the figure 5.7. And here we can see that the optimal allocation to be invested in the large cap growth mutual fund, which is equivalent to 10.8%, which stands for LG. Next is the small cap growth mutual fund, which the optimal allocation to be invested is 41.5%. Kaning SG. Then kaning 47.7% in a small cap value mutual fund, which stands for SV. Then, ang iyang objective function value shows that this allocation provides a maximum expected return of 17.33%. And then, so from the surplus variables, makita nato diri na ang scenario 3 and 5 kaya ang iyang value na makuha nimo or ang portfolio return kay only 2%. So meaning ani ang kaning siyang duha kay mo gitawag na to worst case scenario na mahitabo. So, kung mag-invest ka diri sa using the moderate risk portfolio model. Then also we can see that the returns will be excellent if scenario 1, 2, or 4 occur. Diri makita nato na ang scenario 1 ang value niya kay kuan 21.093 which is dako kayo. Then sa scenario 2 sad ang iyang equivalent kay 21.149. Then also the scenario 4 which is 31.417. So the moderate risk portfolio exposes hawk clients to more risk than the maximum portfolio developed for a conservative investor. Kay dili man sa maximum portfolio, ang worst case scenario na niya kay maka-provide return of 6.44%. Pero dito sa moderate risk portfolio, ang iyang worst case scenario kay duha ka buok, ang kaning scenario 3 and 5, which only provides a return of 2%. Pero mas nindot paghapon pilion ang moderate risk portfolio kay bisag dako man siya kanang worst case, bisag daghang siya risk na makuha nimo kung imo na siyang pilion, di na to risk na makuha nato, di na to malikaya na ang kanisang moderate risk portfolio kay maka-provide nimo possible higher returns or profit na makuha nimo sa imong pag-invest sa mga funds. Then the formulation we have developed for a moderate risk portfolio can be modified to account for other risk tolerances. For instance, if an investor can tolerate the risk of a no return, the right-hand side of the minimum return constraints would be set to 0. And if an investor can tolerate a loss of 3%, the right-hand side of the minimum return constraints will be set equal to -3. In practice, we would expect Hawk to provide a client with a sensitivity analysis that gives the expected return as a function of a minimum risk. So when we say sensitivity analysis in a linear programming, it measures the degree to which a solution responds to modifications of the elements of the analysis, such as the objective function coefficients. So kaning objective function nagrepresent ni siya the mathematical function na imong to work on. Thus, in providing the sensitivity analysis, it enables the managers to adjust the linear programming results to their specific environments in practice. By that, ang kaning linear programming models can be solved quickly, so it is certainly practical to solve a series of linear programs where the minimum return is varied from, for example, -5% to 15% in increment of a 1%, and the optimal expected return is calculated for each value of a minimum return. Then, if the portfolio managers already provided the sensitivity analysis for the portfolio na ilang gamiton, then ang kaning client pwede sila maka-select og expected value and a minimum return combination na feel nilang most consistent with the risk preference. That's all for the moderate risk portfolio. Now, for the asset allocations and variable annuities. So insurance companies use portfolio models for asset allocation for their clients who purchase variable annuities. So when we say variable annuities, mo na siyang insurance contract that involves an accumulation phase and a distribution phase. Diri sa variable annuity, mo sila kaning contract mo sila siya ang kanang contract na imong gipalit from the insurance company, which is designed to help the accumulate assets to provide income for the retirement. Also, ang kaning variable annuities, mo ni sila mga investments products with insurance features, which allow you to select from a menu of investments choices, typically the mutual funds. Then in the accumulation phase kay ang individual, which is you or ako, either makes a lump sum contribution or contributes to the annuity over a period of time. So when you say lump sum contribution, mo ni siyang murag gitawag na to amount of money due na imong gihugdan og bayad, which is ikaw ang bayad ana. In the distribution phase, the investors receives payments either in a lump sum or over a period of time. The distribution phase usually occurs at a retirement, but because of a variable annuity is an insurance product, a benefit is paid to the beneficiary should the annuitant die before or during the distribution period. Next, ang clients with low level risk of tolerance are guided to portfolios consisting of bonds and T-bills, and the most risk-tolerant investors are guided to portfolios consisting of a large proportion of a growth stock mutual funds, while the investors with intermediate or moderate risk tolerances are guided to portfolios that may consist of a suitable mixtures of values and growth stock funds as well as some bond funds. So that's all for the asset allocation and variable annuities.